One of the most important X-ray telescopes, Chandra, is a part of NASA's fleet of great observatories, like Hubble. This is the most powerful X-ray telescope in space and was launched in 1999. Chandra allows astronomers all over the world to receive quality X-ray images of distant galaxies. Because of its greater resolution, it's able to detect X-ray sources more than 20 times fainter than any telescope before it. Chandra makes these observations from more than 86,000 miles above Earth. It helps scientists to begin to answer fundamental questions about the beginning of the universe, its evolution, and its destiny. This telescope has expanded the high-energy universe by recording X-ray images of star clusters, supernova remnants, and collisions between galaxies. It has examined the effects of black holes and provided evidence for the existence of dark matter and dark energy. Astro 1 was a large observatory in orbit around Earth since 1990. The Astro Observatory consists of 3 ultraviolet telescopes and an X-ray telescope. The main objectives of this observatory were to obtain images in the spectral range and make deep space discoveries, especially those that haven't been viewed in ultraviolet lenses. There were several technical glitches in its history, meaning that less data was collected than expected, but Astro 1 still made progress in its field. However, it returned the same year that it was launched after only 10 months in orbit. There were 231 reliable observations made by Astro 1, which would be followed up by Astro 2. The Fermi telescope was launched into space June 11, 2008. Its purpose is to observe the cosmos using the highest energy form of light. It observes light in the photon energy range of 8,000 electron volts, far greater than the human eye can see. Fermi maps the sky every 3 hours from its orbit using the Large Area Telescope and the Glass Burst Monitor. The Large Area Telescope can see over a huge area to detect gamma ray bursts, while the glass helps detect specific bursts. Fermi has been increasing our knowledge of them and the black holes that cause them. Fermi has been making new discoveries almost every day and will continue to observe. GALEX, or the Galaxy Evolution Explorer, was an orbiting space telescope designed to observe the universe in ultraviolet wavelengths. It allowed astronomers to solve mysteries of the early universe, like how it evolved, and characterize phenomena like black holes and dark matter. This was possible because of the advanced ultraviolet telescope inside it. GALEX was launched in April of 2003 and orbited about 428 miles above the Earth. One of its major discoveries was its recording of a giant star eruption that was 1 million times more energetic than what our sun could produce. In 2006, it was able to record the process of a black hole eating a star, and it also discovered the Frankenstein galaxy. GALEX was decommissioned in June 2013. Genesis was designed to help understand the beginnings of the universe. It was launched in 2001 to collect solar wind samples to be studied on Earth. It sent back information and various samples with its return capsule in 2004. The samples were crucial to evidence that the Earth may have been formed from different nebula materials, like those that make up the Sun. The return capsule was the first since the Apollo missions, making it a large astronomical landmark. There was an issue with the parachute involved in the capsule's landing, but the samples were still intact. Genesis used plasma spectrometers to evaluate its location and deploy the sample collection arrays to gather samples. The Hubble telescope is named after Edwin Hubble. He used the largest telescope of his time in the 1920s to look at galaxies beyond the Milky Way. Hubble was launched in 1990, becoming the most significant astronomical advance since the first telescope made by Galileo. Hubble has several sensors to detect its position and orientation, and different actuators that receive information from the sensors to correct the telescope's location. It's in orbit 353 miles above Earth and has made some major discoveries, like evidence for dark matter, Nix and hydromoons of Pluto, evidence for gamma ray bursts, the rate of expansion of the universe, black holes, and the age of universe, which is roughly estimated to be 13.75 billion years. Hubble's major setback was the spherical aberration problem, discovered right after launch. This was caused by a malfunction of a measuring device involved in the polishing of the mirror. It polished the edges slightly too flat, making Hubble unable to properly focus. The telescope is still active and will continue to discover and document deep space until 2020. SAMPEX stands for Solar Anomalous Magnetospheric Particle Explorer. It launched on July 3, 1992, in order to examine charged particles that come from outside our galaxy, often from supernova. Because the telescope is in orbit, it's outside of Earth's magnetic atmosphere, so these particles can be observed. SAMPEX also looks at anomalous rays, or solar energetic particles from the Sun, and magnetospheric electrons, which come from solar wind. Observations made by SAMPEX have provided new information about cosmic elements, the composition of faraway planets, the structure and processes of the Sun, and the processes by which solar energy injects energy into the Earth's atmosphere. SAMPEX was retired in 2004 after many discoveries about interstellar space. SWIFT is designed to study gamma ray bursts to find their origins. They're flashes of light that burn as bright as a billion stars. This telescope is capable of quickly locating the bursts, studying them in different wavelengths. Once a gamma ray burst is detected, the X-ray and optical telescopes and the gamma ray detectors all rotate to view the burst. These bursts are caused by black holes that come from dying stars. SWIFT was launched in 2004 as a part of the 30-year venture to understand gamma ray bursts. It operates in low Earth orbit and has detected some important gamma ray bursts, like GRB 090423. It's one of the most distant confirmed objects in the universe, if not the furthest. It's about 13 billion light years away. Some of SWIFT's other discoveries include measuring the metallicity of star-forming regions and finding the best evidence for a massive black hole in NGC 5408, a galaxy in Centaurus. SWIFT is expected to continue orbiting and observing gamma ray bursts. The Voyager 1 and 2 spacecrafts have gone further into space than anything else Earth has sent before. Their purpose is to explore deep space and record any findings. They are both continuing their nearly 40-year journey that began in 1977. Voyager 1 passed Pluto in 1990 and took the first ever portrait of our solar system. In 2012, it entered interstellar space. Voyager 2 is currently in the Helios Heath, an area just before interstellar space. Voyager 2 isn't as deep into space as its partner because it paused to visit the outer planets, like Neptune and Pluto, to take images and gather information. Both spacecraft are in constant communication with scientists using the DSN, or the Deep Space Network. They've made the best observations of Jupiter's moons, they've been the only spacecraft to pass the outer planets, and they've gone deep into space to expand our knowledge of the universe. Voyager 1 and 2 are still on the VIM, or Voyager Interstellar mission, that will take them both further away from the Sun's sphere of influence to continue their exploration. WISE, the Wide Field Infrared Survey Explorer, was launched on December 14, 2009. By early 2011, it had scanned the entire sky twice using infrared light. It took pictures of 750 million objects, including remote galaxies, stars, and asteroids. WISE is made up of two main sections, the instrument and the spacecraft bus. The instrument is a 40-centimeter diameter telescope with 4 infrared detectors. WISE uncovered millions of hidden black holes and located the possible source for a certain group of dark asteroids. It was deactivated in 2011, but was reactivated 2 years later to scan for near-Earth objects. The second installment of the expeditions are called NEOWISE. NEOWISE is mostly done with the 6th coverage of the entire sky. Over 547,000 infrared measurements have been made and over 23,500 different solar system objects have been observed by WISE and NEOWISE.